Hey guys, and welcome back to the RPG tutorial series with Kotlin LibGDX and LibKTX. So in the first part we did the basic project setup, and we are now able to create a window with a black background screen or just background color, which is of course amazing and very exciting, but now we want to improve on that and make the basic game setup so that we can render now some textures and some graphics to our screen. So for that we go into our core project that we have learned last time, contains all the important code. We can actually also delete those Java folders because we don't use Java. So here we are going to change something. So as mentioned, this class is our entry point and is actually used by the desktop launcher. So let me quickly show you that again. So in here you see that for this lightweight Java game development library, I really need to look up what that acronym stands for. But in here you pass in the class, so the entry point of your game, and then some configuration stuff, so like the title of the window screen, what kind of icon it should use. We could also use here, I think there is a vsync setting, if I remember correctly, that you can enable that. So for example, the vertical synchronization to lock your frame rate to the monitor refresh rate, and things like that. So for example, we could set that here to false, then it doesn't use that. So there you have different configurations, but the important part is here this class, and that is the entry point of our game. And there LibGDX has a so-called application listener, which is the basic of all LibGDX games. And with the listener there comes also an adapter, which is just some default implementation of the different methods of a listener, and that you've seen what a listener can do. So whenever you're going to develop a game in LibGDX, you need to be part of a specific life cycle, let's say. So in the background, OpenGL is used, and LibGDX is booting up everything that is needed to work then with OpenGL. And the first point in time where you can then really act on something with this specific context, let's say, is then the create part of this life cycle. So this is the initial call to our game, let's say, where we want to do some initialization stuff. So some things that we learned then in this part, like setting up a sprite patch to draw the different sprites to the screen. So a sprite is nothing else than, let's say, a graphic like the player graphic that we have seen in the first part, or the slime. That one is referred to as a sprite, for example. And then we use the sprite patch to render that with OpenGL. Then there's a resize method. So whenever we would drag and drop, so for example, when we open up our window and we would drag and drop it or resize it in some way. So like now, for example, I can make it bigger. And whenever that is happening, so whenever the window size changes, then this resize method here is called. Then we have the render method. So this is simply called every frame. So the more frames per second your application can run, the more often this method is called. And in there you have then access to a specific timepiece information, which is called the so-called delta time, which is simply the time between the previous frame and the current frame that you are in. So this render is, some people also refer to it as a game loop. So this is the endless loop function that gets called in your game. Then there is pause and resume. Not sure if that is called on the desktop backend. I would need to look that up. But for example, on your phone, if your game would go into the background because your mother calls you, then the pause function would be called, and when it's then back on focus, then the resume function would be called. Not sure if that works on the desktop backend. We could try that out, but it's not important. So we don't use that for our game, but just that you have heard of it. So this is this pause and resume. And then the dispose function, which is called usually when your application closes, and this is necessary to free up some resources that you are allocating. Like there's simply just special resources when it comes to LibGDX game development, and that one, so if they implement a so-called disposable interface, then you need to take care of disposing those. So that could be, for example, like a texture that you are loading into memory, And then when you no longer need this texture and you want to free it up, then you need to call the dispose function to free up this memory. So this is the basic life cycle of libGDX. And we are developing a game, and there is a special way of an application adapter, let's say, which helps us with game development to be more flexible and to have a better framework in the background to support different sceneries. So for example, imagine you have maybe a loading screen at the beginning of your game, so where you load all your assets and the sound, music, graphics and so on. Then you would switch to a menu. In the menu, the player can select maybe the different settings or load a previous game or start a new game. Then you would change the scene again to the game itself and things like that. And to support that, there is a so-called KtxGame extension or class available. It's not an extension, it's a class. And for that game, you need to say what kind of scenery objects you are going to use, and those are called usually screens. So KtxGame and screen are simply Kotlin extensions from LibKTX, as you see it here, for the libGDX game and screen stuff. And what is that? To put it simple, so the game is simply a special implementation of the application adapter that we have seen before. We are not going to implement all the necessary methods. We just need the create function for the time being. And the screen is then as mentioned before, so for example, the loading screen would be a screen, then you have a menu screen where you have your user interface stuff, then you have a game screen where all your game stuff is working. It's like a separation of the different logic and the different scenes that you need in your game. And maybe that does not make complete sense to you, but in a moment it will. So as we said before, we going to need to implement the create function because that is the entry point of our application. And for our game, we need like an initial screen. So what is the first screen that we are going to show to our players? And there we need to call a so-called addScreen function and create then a specific screen instance. So for me, I will call it a game screen. We create this class in a moment. So that will be then added to this KtxGame, which keeps a list, let's say, of all the available screens that you're going to add to it. And then you can simply set a specific screen whenever you need that. So we are going to set the screen afterwards, which would be our game screen. So next thing, we are going to need to implement our screen here. So for that, I'm going to create a new package. Let's call it screen, and we are going to make a new game screen class. And as we have seen before, it should implement this KtxScreen. Okay, what is a screen? So this is also just a basic implementation of the libGDX screen, which has also methods for show, render, resize. So it's similar to the application listener that we have seen before. The difference here now is that, as I mentioned, the game can have multiple screens, but there can only be one active screen at a time. And you can switch through those different screens. So for example, go from loading to menu, from menu to game, and so on. And there we will always have this show method when a screen gets active. So then its show method is called. And when it gets removed, so when we switch to a different screen, then from the current active screen, the hide method will be called because it's now the screen gets now hidden. And from the new screen that gets set, it will then call the show method. And the other things, those are, as we have seen in the application listener. So render, again, here we already have this delta time, so the time between two frames, that is automatically available when we use the game instead of the application listener. And then we have a resize, as we have seen before, this pause and this resume and this pose method. Good, so we have our screen here, we have our application here. Let's import that here, so that should now work. And just to verify that this is really working, we will add just some simple log information, which we could do with a print line, but that you have also seen that we want to use a logger for that, which could be useful, or which is useful for game development in many areas when you want to debug something. So we are going to make one of these logs with the KTX extensions logger. We want to have a logger for our screen. That's it. And when our screen gets shown, we simply want to log a debug message which says game screen gets shown. So what I think the basic log level, I think, is information. So our debug information won't show up, but we can also fix that easily. So in our application, we simply set the log level with this GDX app log level, and we set it to the debug level. So there would be different levels, just to show it to you. So you can log information on an information level, you can log on an error level, on debug level, or on none. None would mean that nothing gets logged. Info means that info and error gets logged. Error means that only error gets logged, and debug means debug info and error gets logged. So everything, and since we are starting from scratch and developing something new, we want to have that available. So let's start our game, which should show us now an information. So there we see now debug information, our game screen gets shown because we add it to the game, and then we set this as the active screen, and with this set call we are then actually calling this show method of the screen. This is how this basic setup of a game and screen architecture is working. Good, but the black window screen is quite boring, so we want to get some graphics now in there. And for this project, we are going to use the Mystic Woods assets pack. So I will add the link to the video description below. So just go to itch.io. There you can browse for game assets somewhere. Yes, here, for example. So this is what I'm using. Then, for example, we can limit it to 3 assets. And there you will see this Mystic Woods asset pack. There would also be a version where you need to pay for it. I think it's not expensive, I don't know, $2 or something. Then you get, for example, like the skeleton, which is not part of the free asset pack, and some additional scenery stuff for the map. But we are going to use the free version, because the paid version I would not be allowed to share, of course. You would need to pay that for yourself. So that's why we are going to use the free version. And there, just download it. So download now, then we say no, bring us to the free version, and then just download it. And with the graphics inside here, so the sprites, so there you see this again, this word. From this sprites folder, we currently are only interested in the characters, and we want to bring in this player graphic to our game. So for that, what I always do is that I create a separate folder in my game project, which I call the raw assets, which is different to the assets folder. So this folder is used for the game, as we have learned in the first part. So there you put in all your graphics, audio files, map files, and so on. And then I usually have this raw folder for graphics that I need to adjust usually before I can use it in my game. Because as always with this free graphics, people are just providing that in a specific way. But usually we, for our game development purposes, we needed it in a special way. And yeah, so that's why we need to make some adaptations maybe, and we want to have there a clean separation between the original files, which would be for me the raw format, and then the files that are then used in the game itself, which would be part of the assets folder. So for now, we just put in here this player graphic, and for this part, to keep it easy, we also put that now directly into the assets folder, because we will use it. So there I create a subfolder graphics and just put in here the player sprite, which is, I guess, a PNG. Let me quickly check. Okay, yeah, it's a PNG, so player PNG. And that one we are going to render now on our screen, so that you have seen it. So this entire graphic here, that one we will draw now to our screen. So coming back to our game, so what do we need now to render certain things? So in my other tutorials, I always used a sprite patch, and then we rendered the texture directly with sprite patch calls. So just that you seen that what I did in my previous tutorials usually was that I created a sprite patch, which is a so-called patch in libGDX. And then we need to overrule our render method, of course. And in there we can use the sprite patch and then a KTX extension, which is called use. And in there we could then draw our texture. Let's also create our texture here. So private. So we are going to create a texture, and that is simply a new texture. And I guess I can pass in here a file path, which for us would be assets, graphics, and then our player PNG. And then in here we could render our texture. I think it's, how's it called? Draw? Yes, draw. And there we could pass in here our texture and, for example, draw it at the 0, 0 coordinate. And that would be it. So this is something that I did in my previous tutorials, and you could look that up. But for that series here, I want to do it in a different way, just to show you some alternative version of how to render certain things. And for that, we are going to use Scene2D, which is a scene graph and also a part of the libGDX library. And there, instead of drawing it on the, let's say, the lowest level and also the most efficient level, so here simply with the sprite patch and the drawing of the texture, it's the, I would say, the fastest way of you can do that. But we abstracted a little bit higher with the Scene2D library, and there we will work with a so-called stage, which is a scene graph of different actors. I will add a description link in the I will add a link in the video description where you can look up some things about Scene2D. And yeah, this stage, there you can add then certain actors to it. So for example, the different sprites. And this actor always has, or in our case, we will use a so-called image actor, and that actor has then a graphic, so a texture attached to it, and it automatically has a position and a size and a rotation and a color and a lot of fancy things which are then cool to use. So we don't use that approach as mentioned here. So here we use now a different one. So we use a so-called stage. And what does a stage need? So a stage needs a viewport, and it also needs a patch. So the patch, we do not need to provide it here, because if we don't provide it, it will simply create a new sprite patch internally, which is totally fine for us because that is what we are going to use. But we need to provide a viewport. And what is that? There, to explain it quickly, when we would render a texture, which we already do because of the code that we have used before, it's not perfect. But with this texture now, when we would now resize the screen, then the viewport takes care of how to scale the different graphics. So it could simply stretch it, so meaning that whatever, yeah, the aspect ratio of the graphic will not remain the same. So as you've seen it here, it's now shrinking a little bit, so it gets smaller, and it's not the correct aspect ratio of the original texture. And yeah, the viewport is simply helping with that. So there's a lot of mathematical stuff happening in the background, and there are a lot of different versions of a viewport available. So the simplest one would be the stretch viewport, which simply makes your screen fill up with all the graphics that you have, but it destroys the aspect ratio if it is not correct, as you've seen it here. Then there would be a fit viewport where you define an aspect ratio, and that one is then kept. And if your screen is getting too big or too small, then it's simply adding some black bars at the top or bottom, or right or left, to keep your graphics with the defined aspect ratio. But that could be for that it maybe needs to shrink the entire scene a little bit, and then you would get bars at the, as mentioned, right, left, top or bottom, depending on what you have. And what we are going to use for that game here is a so-called extend viewport. There we need to define the minimum world width and height. So we want to have a 16:9 resolution, and that's it. And what is the extend viewport doing? It's like the combination of the fit viewport and the stretch viewport. So it will keep our aspect ratio, and it will simply, as the name suggests, extend the view depending on where it can extend it. So if for example we have 16:9, but our screen would be maybe a 21:9, then it will simply extend the width of the world to fill up the entire screen, but keeping the aspect ratio of the graphics. And same would be for the height. So that's why we use this extend viewport here to fill out the entire screen, but keeping the aspect ratio. Here you always need to think a little bit of what kind of game you're going to develop. For example, a strategy game. There you don't want to have that maybe players have an advantage based on their resolution, so they should always see the same piece of information or the same scene, no matter what kind of resolution they have. So there it should be fair, and an extend viewport might not be the best solution. For an RPG, like in this case, it doesn't matter. So whatever the player has, what kind of resolution he has available, he should simply see whatever he can. That's why we are going to use the extend viewport. So then the sprite batch, we don't need that. Then a stage. As mentioned, there are always these disposable resources, and the stage is one of those. So we need to take care to dispose our scene. Okay, and then there is also the view, so the viewport itself of the stage, and whenever our screen size changes, then the viewport needs to be updated as well. So to do the mathematical calculations to give the correct support for that specific viewport. So here we are just going to get the viewport, and then we are going to update it with the new width and height of the screen, and we are going to center the camera again when we are doing this resizing. Good, then the next part, since we are not using now the sprite patch for rendering, we are using the stage. And when you use a stage, there are always two methods that you need to call. The first one is the act method, where we pass in a delta time, and the next one is then the draw function. So what is that? As mentioned, so a stage can have multiple or different actors, and the actor always has some extra functionality. It's not just a texture that we are blindly drawing. It also contains, as mentioned before, the position, the size, the rotation, the color, and in addition, in Scene 2D, any actor can have so-called actions. An action would be, for example, to fade out an actor or to move it from one area to the next one within a certain amount of time, or change its color over time. So those are actions. And to update those actions and the actors where they are linked to it, we need to call this act method. We don't use that in this part, but it's always a good practice to have it here available, that we see that. And that if we would add actions, that they would then properly work. Then let me simply check the draw method. Okay, so I forgot that. So that is doing it internally, but it is important for you to know. So first of all, a viewport always has a camera. You can imagine that like in a movie. So you have a scene of the movie, and of course behind that scene there is a camera which is filming that specific scene. And the camera can then of course move around, you can rotate it, the camera can zoom, and all this information is part of this camera object. And then in the end, whatever configuration your camera has, so its location, where it's looking at, what kind of zoom it has applied, this is then defining what part of the scene you are then actually seeing on the screen. So what it's doing there, so whenever you modify anything of the camera, so when you move it, rotate it, whatever, you always need to call this update method, which is done internally in the stage to, again, do the mathematical stuff in the background to make it work correctly. And then when it comes to the rendering, as we have seen it before quickly, it uses this patch. And there it's then drawing this root actor. So the root actor is simply the root of the scene graph, and below that we have then the different actors. So we add an actor soon, then you will understand that. But for the important piece for you is simply that everything that is added to the stage, every actor simply gets drawn with the sprite patch in the background. And before you can draw something with OpenGL, you always need to tell it, you need to define this so-called projection matrix, which defines, similar to the camera, what kind of information you see of your scene. And for that, you always provide this camera combined information. So this combined matrix from the camera, I think it's a 4x4 matrix, defines the necessary information, like where are we? So I think the position, so the translation, then the rotation, and the scaling, from what I remember. I think those three information are part of this matrix, and with that information our graphics get then rendered in a specific way. Okay, so the scene is doing all of that, or the stage is doing all of that for us. So that would be sufficient, but right now our stage would not render anything because we haven't added an actor to it. And that is what we are going to do now. So when our screen gets shown, for simplicity, we will add now an actor. And what is our actor? Our actor is a so-called image actor. And that one takes a texture. So here we will simply provide the texture from our player that we have loaded before. And with the image we can do certain things. So for example, we can set the position. Let's say that is 1 by 1. Then we can set a size, which is maybe also 1 by 1. We could set a color. What is important or what is interesting would be the scaling. So let me show you here. So this is cool and an advantage to the low-level stuff that I did in the other tutorials. With Scene2D and this image actor, you have already an option available on how to render, let's say, your graphics. So you have an actor with a specific position and size. So that would be like a rectangle. And now you can define how the texture should be drawn. So should it be stretched? Again, it would then destroy the aspect ratio but fill out the entire actor size. Or should it try to fit the graphic that we are providing inside our actor? Or should it extend it by the x-axis and so on? So there are different options. The important part is the actor has a rectangle, so the bounding area, let's say. And with that area, or within that area, we can define how it should render then the texture that we are providing to it. So for us, let's say fill. I think fill is the one that I want to have. Scales the source to fill the target while keeping the same aspect ratio. Okay, so that is what we want. So we would have now our stage. We add an image actor to it. We have the position at 1, 1. We have the size at 1, 1. And our viewport is 16:9. So I explain also that in a moment. Why is it so small? Let's see. So one last thing that we haven't done yet is for our texture, we need to dispose it as well. So texture also implements the disposable interface. So we need to take care of it. Okay, and now let's start up our game. And there you see now that we have our image here available. So this is our image actor. It's rendered at the position 1, 1. So that would be here. It has a size of 1 and 1. That is here. And our viewport has 16 units by 9 units. So this is our current screen that we have here available. So everything is working But you might wonder, why did I choose such small numbers for our location? Because when we check out our graphic, like a player that has a size of, I don't know, 200 by something, yeah, 288 by 240. So why don't I use this pixel information here for our game? So there, from what I learned, and also when it comes then to Box2D later on, you should never use pixels as a specific unit in your game world. You should always use your game specific world unit. So whatever that would be. So for example, for us, we simply have this abstract information, let's say. So our world is 16 by 9 units. So this is the aspect ratio of most devices currently, for example, most phones. So our world simply has, or our viewport has a 16 by 9 size. And what is now one unit? So what would be one specific unit? That is now up to us to define. It could be 256 pixels, it could be just 16 pixels, it could be 32 pixels, whatever, it doesn't matter. And for all our logic, so for movement and scaling or whatever, we don't want to think in these pixels. We want to think in these world units. And for example, let's say the default or the default object is 1 by 1 in our world. And for example, if we want to have now a bigger object in there, so for example the normal player human, and then we want to have a giant, then the giant we just want to have it 2 times bigger, so it should be just a size of 2 by 2. And that is pretty easy then to understand, and what you're going to do instead of using pixels where it could change. So for example, you develop this game with 16 by 16 pixels graphics, but later on you enhance it with Ultra HD 4K super amazing textures, and then all your game logic would be screwed up because the graphics that you are using are not compatible with the logic that you are using in your game. And yeah, to avoid that problem, we simply use now our, let's say, virtual world units, and we don't use the real ones. Okay, I think that was a lot for this part actually. To summarize it a little bit again, so we introduced the game objects, so KtxGame and KtxScreen, and we added a screen and set that specific screen in our create method, which gets called when the OpenGL context is started up by LibGDX in the background. Then in our game screen, we created a stage, which will be for our entire tutorial be responsible to render stuff. And the stage always has a list of actors and the so-called scene graph in the background. And it then renders all the different actors to the screen. And as an example, we created this image actor where we provided a texture to it. We set it at a specific position and size, and then we simply rendered it. And since the stage and also the texture are disposable resources, we also needed to dispose them. That is the important part. And there is one thing here that I quickly need to look up why I don't have it available, but with that I want to finalize then this part of the basic game setup. Okay, I found it. So there is one dependency that we are missing. So let's quickly add that. So let's go to our build Gradle file, and I forgot one KTX extensions, which is called assets. So let's add that here and also refresh our Gradle project. And now what we should have available is a dispose safely function or extension, because the normal dispose function could potentially throw an exception. For whatever reason, it cannot free up the resource and then your application would crash. But to be honest, I think that would be a case where you anyway cannot recover and you don't really care because you want to shut down your game. So okay, one texture, for example, could not be freed for whatever reason, but then still continue with all the remaining stuff. And to ignore this exception, there is this dispose safely extension, which calls dispose internally, and whatever exception gets thrown, it gets then simply ignored. So this is I would say a best practice when you use Kotlin, that instead of using the dispose function, use dispose safely. And that would be it. Hope you liked it. And then in the next part there, so now that we have managed to draw some texture to our screen and some graphic, we are now enhance on that and make it now a little bit easier and create our first game objects, let's say, so that instead of having the entire texture drawn that we have right now, just for simplicity, so we draw the entire texture here. So now we are going then to just draw a small piece, and we are going to create a player object and the slime object on the screen in our next part. So thanks for watching and have a nice rest of the day. Bye bye.